For over a century of powered flight, the laws of physics have drawn a clear, uncrossable line between airplanes and helicopters. One is built for speed and range, the other for hovering agility. But what if you didn't have to choose? What if a single machine could conquer both worlds? This question haunted engineers for decades, a dream that seemed to promise unparalleled military advantage. The answer wasn't found in a simple modification, but in a radical, dangerous, and breathtakingly complex reimagining of flight itself. Its story is not one of easy triumph, but of political battles, tragic failures, astronomical costs, and engineering perseverance. This is the story of the machine that refused to be categorized. This is the story of the V-22 Osprey tiltrotor. The dream of a hybrid aircraft is an old one. As far back as the 1950s, companies like Bell were experimenting with tiltrotor designs. The Bell 53 proved the concept was physically possible, but the technology of the era, pistons, engines, mechanical controls, was simply too primitive to make it practical. The idea was shelved but not forgotten. It took a national tragedy to bring it back to the forefront. In 1979, the Iranian hostage crisis exposed a critical flaw in American military capability. Operation Eagle Claw, the failed rescue mission, failed in part because the Navy's RH-53 helicopters, operating at the very edge of their range, were decimated by a desert sandstorm. The military's stark conclusion: helicopters were too slow and short-legged, while transport planes couldn't land in a crowded embassy courtyard. They needed a new tool. In 1981, the Joint Services Advanced Vertical Lift (JVX) program was born. Its goal was audacious: create an aircraft that could take off and land vertically like a helicopter, but cruise at the speed and range of a turboprop airplane. The winning design would come from a team of rivals: Bell, with its proven XD-15 prototype, and Boeing, an aerospace giant. Together, they would build the future. So, what exactly did Bell and Boeing create? The V-22 Osprey is a masterpiece of compromise and complexity. At its heart are two massive 38-foot diameter rotors mounted on nacelles at the end of a straight wing. These nacelles are the key. They can rotate a full 98 degrees, moving from a vertical position for helicopter flight to a horizontal one for airplane flight. This isn't just a tilt of the propellers. The entire engine and transmission system rotates with them. This creates immense engineering challenges. How do you manage the shifting center of gravity? How do you control an aircraft that behaves like a helicopter at low speed and a plane at high speed? The answer is a triple redundant fly-by-wire system, a computer that essentially flies the plane, translating pilot inputs into commands appropriate for its current flight mode. The airframe itself is a mix of advanced composites, 43%, and metals, a necessary step to save weight for its demanding mission. It can carry 24 combat troops, or 20,000 pounds of internal cargo, or up to 15,000 pounds on an external sling. Its performance specs are where the dream becomes reality: a top speed of 315 mph, a range of over 1,000 miles, and the ability to self-deploy across oceans with aerial refueling. The path from drawing board to battlefield was perhaps the most difficult any modern aircraft has ever faced. The Osprey was plagued by problems from the start. Its complexity made it astronomically expensive, causing the U.S. Army to drop out of the program early. In Washington, a strange political battle erupted. The Pentagon was often skeptical, while Congress, swayed by jobs in key districts, repeatedly fought to fund it. But the darkest chapters were written in blood. During testing in the 1990s and early 2000s, 4 prototype Ospreys crashed, claiming 30 lives. The crashes revealed deadly flaws. One was susceptibility to vortex ring state, a condition where a helicopter descends into its own downwash, which was especially dangerous during the Osprey's complex descent profile. Another crash was traced to a hydraulic leak and software error. Each tragedy fueled a media firestorm. Critics labeled it the Widowmaker. The program was nearly canceled multiple times. The pressure on Bell, Boeing, and the Marines was immense. They implemented sweeping changes, new training simulators to teach pilots to avoid vortex ring state, redundant hydraulic systems, and millions of lines of rewritten software code. They had to prove this machine could be tamed. Despite the controversy, the Osprey entered service with the Marine Corps in 2007. Its baptism by fire came in Iraq and Afghanistan, and slowly a new narrative began to emerge. Troops on the ground gave it a new nickname: the Vulture. Because when you called it, things died. Its speed was its greatest weapon. It could insert special forces teams from hundreds of miles away, far from enemy air defenses, and be back before anyone knew they were there. It revolutionized the mission of the Marine Corps, allowing them to operate from ships far over the horizon. The Air Force's Special Operations CV-22s became indispensable for long-range clandestine missions. The Navy eventually came back, adopting the CMV-22B to replace the C-2 Greyhound for carrier onboard delivery, ferrying crucial supplies and people to aircraft carriers. The Osprey has even been tested as an aerial tanker. While its operational costs remain high, its unique capabilities have made it irreplaceable. Over 400 have been built, and they have collectively flown over 500,000 flight hours. The machine that was once a symbol of failure is now a cornerstone of American tactical aviation. The V-22's true legacy may not be the aircraft itself, but the door it kicked open. It proved that the tilt-rotor concept, despite its immense challenges, was viable and operationally valuable. It paved the way for the next generation, like the Bell V-280 Valor, which seeks to leverage the lessons of the Osprey to create an even more capable and affordable aircraft. Japan is the only international operator so far, but others are watching closely. The dream now extends beyond the military. Could tilt-rotors revolutionize search and rescue, executive transport, or even civilian commuting? The Osprey answered the fundamental question. Yes, an airplane can be a helicopter. It did so at a tremendous cost, both in dollars and lives. But in doing so, it created an entirely new category of flight and secured a permanent place in aviation history. So, what do you think? Was the V-22 Osprey a revolutionary triumph of engineering or a scandalously expensive lesson in overcomplication? What feature, its speed, its range, its sheer mechanical audacity impresses you the most? Let us know in the comments below. If you enjoyed this deep dive into one of aviation's most controversial machines, make sure to like this video, subscribe to the channel, and hit the bell icon so you don't miss our next exploration. Thanks for watching. Of all the technical challenges the Osprey faced, one was particularly deadly: vortex ring state, or VRS. This is an aerodynamic nightmare not unique to the Osprey, but its design made it especially vulnerable. Imagine an aircraft descending too quickly without enough forward airspeed. Its rotors get caught in their own turbulent downwash, losing lift dramatically and causing an uncontrollable descent. For a helicopter, recovery is difficult. For the Osprey, with its large, high-disk loading rotors, it was often unrecoverable if entered too deeply. The 2000 crash in Arizona that killed 19 Marines was a classic VRS accident. The aircraft was descending too fast on approach. The pilots, trained on helicopters, may not have recognized the onset of the conditions specific to the Osprey's flight envelope. This tragedy forced a revolution in training. Now, every Osprey pilot undergoes extensive simulator training to recognize and avoid the conditions that lead to VRS. The procedures are drilled into them. If they sense VRS, they must immediately execute a drastic power pushover, nosing the aircraft down to gain forward airspeed and fly out of the turbulent air. This training has been highly successful, making VRS-related accidents exceedingly rare in recent years. The Osprey's cost debate has two sides: staggering upfront price versus unique operational value. With a unit cost of around $70–80 million, one Osprey costs more than two MH-60 Seahawks. Its operating cost is famously high, at over $10,000 per flight hour, much of it due to the intensive maintenance required on those complex rotating nacelles and gearboxes. Critics ask, could we have bought more helicopters and achieved the same result? The Marines argue the answer is a resounding no. They don't see the Osprey as just a better helicopter. They see it as a system that fundamentally changes strategy, a formatio. And of Ospreys can launch from an amphibious assault ship hundreds of miles offshore, far outside the range of many coastal defenses, strike a target inland and return without the ship ever needing to get close to danger. This concept, known as ship-to-objective maneuver, was impossible with traditional helicopters. The cost, they argue, isn't for an aircraft, but for a strategic capability that didn't exist before. It's a floating truck, a medevac vehicle, a special operations insertion platform, and a long-range logistics hauler all in one. Its speed was its greatest weapon, but another less discussed advantage is its altitude. While helicopters typically operate at G-Chen-Ying-Chi, a few thousand feet vulnerable to small arms fire and RPGs, the Osprey can cruise at altitudes up to 25,000 feet, like an airliner, putting it safely above most common battlefield threats for the majority of its journey, only descending for the final approach. This capability was showcased in a 2013 mission in South Sudan. 2 CV-22s were sent to evacuate American personnel from the city of Bor. As they approached the landing zone, they were hit by sustained small arms fire. The aircraft were riddled with bullets. One took over 100 hits, which damaged hydraulics and fuel lines. Yet the Osprey's robustness and redundancy allowed them to complete their landing, load personnel, and take off again. While the mission was aborted due to the damage, the fact that the aircraft stayed airborne and brought their crews home safely was a powerful testament to their combat survivability. Despite its hardened service record, the Osprey's safety concerns have never fully vanished. A cluster of fatal crashes in 2022 and 2023, including one in Japan that killed 8, led to a full, unprecedented global grounding of the entire fleet for months. The suspected culprit, a hard clutch engagement within the intricate gearbox system, a failure that could lead to a catastrophic loss of control. This grounding was a stark reminder that the Osprey remains a demanding and complex machine whose technical risks must be constantly managed. As the fleet returns to flight with new inspection protocols, the question of its legacy is intertwined with its future. The Osprey was the pioneer, the proof of concept that broke the mold. The next-generation tiltrotor, the Bell V-22 Valor, which recently won the contract to replace the UH-60 Blackhawk, is the beneficiary of its hard-won lessons. The V-22 features fixed engines that only tilt the rotors, simplifying a key mechanical complexity of the Osprey. The Osprey's story is ultimately a human story, one of ambition, tragedy, perseverance, and the relentless, often painful pursuit of a revolutionary idea.